Zombie apocalypse.
Hello everyone, welcome to Eco Talks with Sneha Monerikar. In today's session, we'll start new topic, that is linear programming. So let us start our session with first question. Operation research or OR, which is very powerful tool for A, research, B, decision making, C, operations, D, none of the above. Operation research, also called in short form, it is called as OR. It is a powerful tool for decision making. The operation research, it is a new discipline, relatively new discipline. It was introduced during 1950s. So therefore, it is formal definition of the term operation research is a difficult task. OR starts with mathematical and quantitative techniques are used to substantiate the decision being made. That is, it deals with application of scientific methods for making decision and especially to the allocation of scarce resource. The main purpose of operation research is to provide a rational basis for decision making in absence of complete information, because the system is composed of human, machine and procedures may not have the complete information. The basic operation research came into existence. This stream or this discipline came into existence just to allocate the scarce resources in the production process or manufacturing process. This is a multidisciplinary approach. Next question is, who coined the term operation research? A, J.F. McCloskey, B, F.N. Trefton, C, P.F. Adams, D, both A and B. Answer is, the term operation research was coined by both A and B, that is J.F. McCloskey and F.N. Trefton. They coined this term in 1940, McCloskey and Trefton, in a small town, Babsey in England. So, operation research is defined by various persons. Like operation research is a scientific method of providing executive departments with quantitative basis for decisions regarding the operation under their control. Or it is also defined as it is a scientific method of providing executive with an analytical and objective basis for decision. The other person, that is T.L. Sati, he defined as it is the art of giving bad answer to the problems to which otherwise worse answers are given. So likewise, these are the various persons who defined the operation research in different ways. Next question is, this innovative science of operation research was discovered during A, Civil War, B, World War I, C, World War II, D, Industrial Revolution. Answer is, the operation research discipline was discovered during World War II. The term operation research was, as we have seen in previous question, it was coined by McCloskey and Trefton. And during World War II, the military management of UK called on scientists from various disciplines and organized them to team to assist in solving the strategic and tactical problems relating to air and land defense of the country. The group of scientists which were called, they were required to formulate specific proposals and plans for aiding the military commands to arrive at decision on optimal utilization of scarce military resources and efforts, and so also to implement decision effectively. Hence, OR, that is operation research, can be termed as art of winning war without actually fighting it. So during World War II, UK had very less military resources. So they called the scientists and they asked them to make the optimal plan, that is with less movement of the military, there should be the maximum gain in the war. So in this way, the term operation research or the discipline operation research was developed. Next question, operation research cannot give the perfect dash to the problems. A, answers, B, solutions, C, both A and B, D, decisions. Answer is both A and B. Operation research cannot give the perfect answer and solutions to the problem. Operation research is art of giving bad answers to the problems which otherwise worse answers are given. Suppose there is any problem which is being used in OR. Operation research is carried on that particular problem, then it will not give a perfect answer or solution to that problem, but it will give somewhat good problem solution, which then without applying the operation research. Suppose by before operating the operation research or formulating the model, you are getting having loss of few amount, suppose 100 rupees. Then after applying, if this loss is getting reduced, then instead of worse, we are getting something better than that. So that is, it is art of giving bad answers to the problems which otherwise worse answers are given. For use of technique of operation research, a mathematical model of problem is to be formulated. This model is actually a simplified representation of problems in which only most important features are considered for the reason of simplicity. The complex problems will be broke down to the simpler problem. Instead of this making it simplicity, some of the facts will be hidden. So this will not give the very best answer or best solution to the problem. So it is said that we do not get the perfect or the best answer for the problem through operation research. And operation research simply helps in improving the dash of the solution, but does not result in the perfect solution. A. Quality. B. Clarity. C. Look. D. None of the above. Answer is quality. It will improve the quality of the solution, but not gives the perfect solution. Next question. Linear programming technique is used to allocate scarce resources in an optimum manner in problem of A. Schedule, B. Product mix, C. Both A and B, D. Servicing cost. Answer is both A and B. Linear programming is a technique used to allocate scarce resources in optimum manner in problems of both schedule as well as product mix. Now, linear programming is a mathematical technique for allocating limited resource in the optimum manner. So, it is the problem of schedule and product mix are solved by using linear programming technique. William M. Fox, he has defined linear programming as linear programming is a planning technique that permits some objective function to be minimized or maximized within the framework of given situational restrictions. So in linear programming techniques, we have one objective functions and framework, that is a set of constraints or situational restrictions. Based on that restrictions, we have to find the optimal solution. That is the method of linear programming technique. Next question is, the objective functions and constraints are linear relationship between A. Variables, B. Constraints, C. Function, D. All of the above. Answer is variables. The objective functions and constraints are linear relationship between the variables. Variables will be the input used, different input used, machines used, or labors used. Those are the variables. So these variables will be linear form in both objective function as well as the constraints. Now, objective functions and constraint are linear relationship between the variables. This means that no variables can be multiplied with each other. So here I have stated the standard form of linear programming. Maximize or minimize z is equal to c1 x1 plus c2 x2 plus up to cn xn. This is the objective function. It is denoted by z. Depending upon the criteria given, it may be maximize z or minimize z. C1, C2, xcn, these are the coefficients of variables, and x1, x2, up to xn, these are the parameters of variables. Then subject to constraints, these are the constraints, which are the situational restrictions. Then a11 x1 plus a12 x2 up to a1 x1 xn is equal to b1. Likewise, up to am1 x1 plus am2 x2 to amn xn is equal to bm. These all are the constraints. And the important condition is that non-negative restriction. That is, all the variables are non-negative. That is, x1 is greater than or equal to 0, x2 greater than equal to 0, up to xn greater than and equal to 0. It can be 0, but it cannot be negative value. It will be always positive. This is the standard form of the linear programming problem. Next question is, all the parameters in linear programming model are assumed to be A, variables, B, constraints, C, functions, D, none of the above. Answer is constraints, because the whatever parameters, now if you consider the human labor machine, there is some constraint, that is there is some limitation in the use of the both the inputs. So all the parameters are are assumed to be the constraints. All the parameters in linear programming model are assumed to be constraint. For a problem to be linear programming problem, a decision variable, objective function, and the constraints all have to be linear function. If all the three conditions are satisfied, it is called as linear programming problem. Next question is, the graphic method can be applied to solve LPP, that is linear programming problem, when there are only dash variables A, 1, B, more than 1, C, 2, D, 3. The graphical method is applied only when there are two variables, because on the graph we have only two axes and two variables can be expressed simultaneously only. So when there are two variables, we can use the graphical method to find the solution. Here is the one problem where I have shown the graphical method. The objective function z is maximize z is equal to 5x plus 3y, and constants are 3x plus 5y is less than or equal to 15, 5x plus 2y is less than or equal to 10, and then non-negative constant, that is x is greater than or equal to 0, y is greater than or equal to 0. So you can see here there are two variables x and y. So we can use here the graphical method. Steps for graphical method are, whatever given the constraints, first plot them, find out the line, draw the line on the graph. So here these two lines are plotted. 3x plus 5y is equal to 50. Make the inequalities into equal to 15 and equal to 10. So we have less than. When there is less than sign, we have to take region below the line. So below the two lines, this blue shaded area is the feasible region for which satisfies both the equations. So this is called the feasible region, and from this we can later find out the at which values of x and y the z is maximum. That will be our the optimal solution of the problem. Next question is, if the feasible region of LPP, that is linear programming problem, is empty, the solution is A, infeasible, B, unbounded, C, alternative, D, none of the above. Answer is infeasible. If the feasible region is empty, that is called then the solution is infeasible. This is the special case of graphical method, infeasible problem linear programming. So in some cases there is no feasible area, that is there is no points that satisfy all the constraint of the problem. An infeasible linear programming problem with two decision variables can be identified through its graph. So here is the example of infeasible problem. Objective function is minimize z is equal to 200x1 plus 300x2, and subject to constraint at 2x1 plus 3x2, which is greater than equal to 1200. x1 plus x2 is less than or equal to 400. 2x1 plus 1.5x2 is less than or greater than 900, and the non-negative constraint, that is x1 x2 is greater than or equal to 0. After plotting each equation, the constraints on the graph. Now first here it is first constraint, 2x1 plus 3x2 is greater than 1200, greater than or equal to 1200, means the feasible region will be above right hand side of the line. The region located by the right of PQR. Now here line you can see PQR includes all the solution which satisfy first and third constraint, that is 2x1 plus 3x2 greater than 1200 and 2x1 plus 1.5x2 greater than or equal to 900. This will be here in this region above the PQR. This will satisfy. Whereas the region located to the left of ST is here. x1 plus x2 is equal to 400. Will satisfy the second constraint. So we don't have the common region where all the three constraints are satisfied. So this problem is infeasible because no set of points satisfy all the three constraints. This is the example for infeasible problem. Here you can see there is no shaded area or no common area between the three constraints. That is, region, feasible region is empty. That is nothing but the solution is infeasible. That's all for today's session. If you have any doubts, you can ask me in the comment section. Don't forget to like, share and subscribe. Thank you.